Welcome to this class on Neuroscience of Human Movement. This is part 5 of our discussion on parietal and premotor cortex. Right. So, in this class we will discuss the critical role of the supplementary motor area in motor function and discuss disorders of the supplementary motor area. Let us remember where the supplementary motor area is. So, rostral to the central sulcus is primary motor cortex, rostral to the primary motor cortex is the supplementary motor area. So, this was classified using the classic studies of Clinton, Woolsey, Brodmann and others, right. So, remember in the good old days it was called as the premotor cortex, then it was called as the supplementary motor cortex, but later on it was divided into two regions. So, this is M1, this is the strip that is just rostral to the central sulcus, the precentral gyrus, right. Rostral to the primary motor cortex, you have an area that was earlier called supplementary motor cortex, but the cytoarchitecture of this area has at least two distinct areas or sub areas within itself. These two have come to be called as the SMA proper or the supplementary motor area proper. Right. So, within the supplementary motor area, the more caudal of these two areas is the supplementary motor area proper, and the more rostral one is called as the pre-supplementary motor area or the pre-SMA, right. Importantly, they differ in cytoarchitecture, they differ in connections. So, obviously, they also differ in functions, right. An important concept in understanding movement and movement related function is the notion of readiness potential, right. If a movement is performed by intention, for example, then readiness potential is this potential that is slow in rising at about 0.8 to 1 second before the execution of movement, self generated or self initiated intentional voluntary movements. 1 second is a long time in neuronal terms. We have been talking in the order of tens of milliseconds. Remember, when it came to reflex, as I said, 30 milliseconds is approximately the monosynaptic delay, 40-50 for oligosynaptic and polysynaptic, about 70 or 80 for the trigger reactions, and about 200 milliseconds is the delay that you get for voluntary reactions. But let us remember, these discussions are in response to stimuli, is it not? So, a stimuli is presented, it takes about 200 milliseconds for the first voluntary response to appear, right. This is in response to stimuli, but suppose there is an intention to act, how much in advance is there a preparation that is going on? In that case, the preparation can be about 800 milliseconds to 1000 milliseconds in advance. So, start of readiness potential. So, this readiness potential is something that can be easily observed in EEG, right. So, the start of the readiness potential happens earlier than 600 milliseconds or 550 milliseconds before the start of the movement. 0 here is the start of the movement, but at about 200 milliseconds before the start of the movement is when you become actually aware of the movement. Please note, these two are different. I have already made the decision to make a movement, that is made before 500 milliseconds, but at around 200 milliseconds before the movement is when I think I know. There is a difference between these two, because it is easy to confuse the two. We think we know when the movement is about to start, that you have decided, but you have decided even before you think you have decided. Essentially, the idea that we control our movements, that we control our actions, that we are aware of our actions, and it is this awareness that gives us this notion of control, is really not such a strong argument really. For example, I have already made the decision to make a movement, but only later I come to know that I have made this decision, right. So, that means my awareness itself, or the notion that I am controlling my actions itself is being questioned somewhat. This has been challenged, this idea has been supported by evidence. An important line of evidence in this line of research was provided by Benjamin Libet, 1984. Please do check this paper, a very interesting philosophical treatise of the idea that we think we know. Please do check, those who are interested, please do check this paper, right. Also importantly, the supplementary motor cortex contains a map of the contralateral side of the body. Crucial to note is the difference between the map that is found in the primary motor cortex and the map that is found in the supplementary motor cortex. In the primary motor cortex, you have a detailed map, right. In the supplementary motor cortex, what you have is a relatively non-detailed map of the contralateral side of the body. So, this is different, right. And unlike the primary motor cortex, which maps to specific areas such as hand and legs, the supplementary motor cortex does not map to specific areas such as hand and leg, right. Also, the stimulation required to produce a movement in the primary motor cortex is much less when compared with the stimulation. This is not simulation, but rather stimulation. The stimulation that is required to produce a movement through SMA, right, or supplementary motor area, and the movements produced are not necessarily simple movements. The movements produced are complex movements, as you would expect from a higher order control center such as supplementary motor area. I am using this term, it's a controversial term, without actually providing the evidence to support that idea, but essentially what you would expect from an area such as supplementary motor area is coordination and control of the higher order aspects of movement, not necessarily the nitty-gritty details of the movement, right. And also the readiness potential has its peak in the supplementary motor cortex. The supplementary motor area, it controls execution of movement in motor acts that are encoded in lateral parietal and prefrontal circuits, right. And what are its functions? What are its functions, right? Importantly, organization and execution of movement sequences. Let us take a moment and understand what this means. Take dance form Bharatanatyam, for example. What does this involve? It essentially involves graceful movements, right, that is a pleasure to watch, right. So, it can also be classified. So, movement chauvinists like me who are observing Bharatanatyam, of course, I do not have the flair or the aptitude for appreciating art probably, but what I do have the aptitude for is to appreciate movements in its entirety, right. So, whatever I see, instead of seeing the art, I look at the movements. So, when you see this art form, what I see is a set of discrete movements that have been concatenated, that have been attached to one another, right. But these discrete movements have not been attached in a discrete fashion. It is not like there is a jerky jump from one discrete movement to another discrete movement, but rather what is happening is that there is a graceful shift from one movement to another movement. So, essentially this dance form can be considered to be a sequence of movements, and expertise is when you are not able to observe that it is a sequence of movements, but rather as a whole, right. So, essentially when you observe the dance form, if it is an expert who is performing it, you will not be able to see the discreteness there. What you are seeing is smooth, graceful, artistic, beautiful movements of the person, but these are essentially discrete movements that have been concatenated and smoothened very nicely. It is this practice that gives rise to the smoothing. It is the practice that gives rise to smoothening of these movements, not. So, essentially motor performance or any given motor skill can be considered to be a performance of a set of motor sequences, right. So, supplementary motor cortex probably plays an important role in the organization and execution of movement sequences and acquisition of motor skills. Just now we were talking about Bharatanatyam, but this also applies to other art forms or maybe even sports, right. So, essentially motor skill acquisition. So, essentially playing a sport involves performing a set of motor acts in a particular sequence within a particular time, is it not? So, that also is probably crucially dependent on the function of supplementary motor cortex and probably some role in executive control of behavior, such as switching between actions. Just now I said that there are different actions and you want to jump from one action to another, but you do not want it to be a jerky jump, or suppose depending on the context you want to switch between one action plan to another action plan, is it not? Plans and strategies, right. And suppose there is a situation in which you have to inhibit yourself, you wanted to do something that you would do in private, but somebody else entered and you do not want to do it, that is suppression of a previously intended movement, right. Suppose you are starting to write and somebody comes in to have a chat, you are putting the pen down, right, suppression of a previously intended movement for example. And importantly, contextual control of movement. Compare this with the primary motor cortex, which is primarily an execution engine, is it not? Primary motor cortex or M1 is an execution engine. We discussed at length about what it could be encoding, right. Is it kinematics, is it kinetics, is it muscle function, etc., right. We also discussed what happens during lesions of the motor neurons in the primary motor cortex, right. How does it affect movement function? These are things that we discuss. In this case, in the supplementary motor area case, what you have is the contextuality. It is not the execution engine, but it is something that provides the appropriateness or contextuality to the movement, right. What happens if there are lesions to the prefrontal area or the supplementary motor area? Essentially, if there is disorders of initiation, this could be akinesia or mutism, the person cannot move the mouth for example, or it could be disorders of suppression, right. In this case, this could be due to forced grasping, groping movement. So, you are seeing an object, you know that it is somebody else's object, but you pick it up. Sometimes even when it is socially inappropriate to do so. Let us say that somebody's pen is kept on his table and you go there, but you have this habit of picking up pens wherever you see it, say for example. Then what happens is that even though you know, even though everybody knows that it is socially inappropriate to take someone's pen and put it in your pocket, turns out that some of these individuals who had lesions to the supplementary motor area will actually do this in a compulsive manner, right. Compulsive grabbing without social consideration. And sometimes these individuals actually do not have control of their arm or hand. This is called as the alien hand syndrome. Of course, this results in a tremendous amount of embarrassment and difficulties for these individuals, is it not? So, when you grasp something without your own control, right, it could put you in very big trouble from time to time, is it not? So, for example, if you are picking up a meal from somebody's plate, somebody is eating and you go there, you see a nice eatable entree there and you just pick up a bite, right. Does not exactly look good, right. So, it does give them a tremendous amount of embarrassment and difficulty, right. So, in summary, the supplementary motor area is located anterior to the supplementary motor area is divided into the proper supplementary motor area, SMA proper, and the pre-supplementary motor area, the pre-SMA. The supplementary motor cortex is responsible for executive and contextual control of behavior, right. And lesions of the supplementary motor cortex results in difficulty of movement initiation and movement suppression, sometimes leading to very embarrassing or difficult situations for people who have this problem, okay. So, with this we come to the end of this lecture. Thank you very much for your attention.